Hi sir, this is Joshua Manalo and this is my group mate John Leland Bugay. And this is our project. Currently we're already finalizing the GUI in which we're designing it and we're currently designing the GUI of our project, the digital signals processing, and we're
Trying to put a background.
We're trying to put a background by editing the code.
We found in the internet.
I'm just hard coding in here one of our standard count.code. Now when I run this by hitting F5 to save it on, I have that graphic in the background. It's in the background. We can now put buttons on top of it. I'm going to come in here, put a button like that, maybe a checkbox.
Oh, yeah, sir. So basically, this is how our project works. We are going to our program requires any audio input like voice or music or something, and which we will make that input signal. We will make that input signal pass through a filter in which the user is required to input all the necessary characteristics of these types of filters. So basically, we have the finite infinite response filter type, the low pass, high pass, and band stop filters, and the infinite filter type response, which is the Butterworth, Chebyshev type 1, Chebyshev type 2, and elliptic. So basically, this is how our program works. The program requires the user to input any audio signal which in a time limit of 5 seconds, and we are going to make that input signal either a voice signal or music or any kind of audio signal as an input, and we're going to make that input signal pass through a filter. And in this part, the program requires the user to input what kind of filter he wants that signal to pass through, and we have included in our program 3 types of filter response. So for the first type of filter response, we have the low pass, high pass, band pass, and band stop filter under the finite impulse response type. The next type is the Butterworth, Chebyshev 1, Chebyshev 2, and elliptic, which is very similar to the experiment we have conducted in our lab under infinite impulse response filter types. And the last one is
The last type of the filter is the multi-band pass filter response, in which the user is required to input a number of band pass and band stop frequencies at their choosing, and these band pass and band stop frequencies will then be the design for which the signals will be passed through or filtered, if you will. Yeah, and then the output will be shown here in different graphs. Later, after we will show how the program works later, but right now it's still under construction, so yeah, it's still not finished.
We have also included an option of playing the record back, similar to the experiment, in which if we want to record an audio signal, we have used the command wave record, and if we want to play that recorded message, we have used the command wave play. And after passing that signal to the filter, we have also included an option of playing that signal, that filtered signal, in which we can compare the effects of the response type of the filters to the audio signal. And this is the output of our sample output, and which we have showed the graphs.
The blue one is the original signal, while the red one is the filter signal. As you can see here, this is the original signal being plotted. This one is the filter response. For the pole 0, the impulse response, magnitude, and frequency FFT. You can see all of that here. You also have a function in which, when you click it, it restarts the whole program, and then you can do the recording all over again. You can also hear your recording, the original signal, and hear it. You might not hear it, but because it's not that loud. And we have also an option that you can play the recorded video, recorded sound, recorded audio, the recorded audio which is filtered here. We also have a function in which to set the filter data. This button here executes the function in which, when you click it, the filter data will be erased, and you can filter a new data using the original recorded audio. It's like this one. The first one was an FIR. The next one I will do an IIR filter with a Chevy Type 2, and sampling frequency of 2000 kHz, and an FC of 5000, FC2 of 8000. Okay.
Our program follows the Nyquist theorem, in which the cutoff frequency must always be less than or equal to twice the sampling frequency. Yes. This is the output of the second filter.
The second filter used for the same original audio. If you set again, you can do it all over again like this. And if you want to remove the recording, click here start. The program is not yet finished yet, so we'll still have a few more options to work here. And
we have also included an option in which, if the user did not follow the instructions here, right here, the menu, like that. For example, if the user inputs a filter type that's not included in the menu,
like for example, filter number 4, in which we have only 3 filter types, the program will output an invalid error dialog, which indicates that your input is not correct, and you should just
the user must input another type.
And it's not only true for the filter type. Like for example, you have here the filter type is correct, but the response type is not correct, which I will input a 5 here. We only have 1 to 4 FIR filter, so it will also have an invalid input, in which the program in which you need to input again and click the filter type.
Basically, the program will not run if the user emits incorrect inputs. This is our loop statements for the filters. We have applied what we've learned in the labs, how to use an if statement, how to declare a proper limit for the if statement, like that. And we have also learned how to use the while statement, in which it will continue processing the loop until it meets the requirements and the parentheses.
I just can't won't you like the dark same old story. Once you won't you rain on me tonight? Alright, free ride. Won't you take me close to away. Life